Hi friends, this is Himadri. I am working as assistant professor in the Department of Mechanical Engineering in RMK College of Engineering and Technology. So today I am going to discuss about in heat treatment process. We will see the case hardening process, carburizing, nitriding, and flame hardening and induction hardening. So first we will know the what is meant by surface hardening. So normally when we are using the gears, camshafts, bearings, clutch plates, tools, so all these components it will require the hard and wear resistant surface. So then only it will withstand some sudden shock loads. Otherwise component will failure. So because of this purpose we can do the surface hardening. So we can improve the properties of this materials. We can do the two types of heat treatment process. So first one is we can surface hardening. We are having the two types, flame hardening and induction hardening, and some chemical heat treatment, that is called case hardening. Case hardening means so it will change the composition of the surface layers like carburizing, nitriding and cyaniding process. So we can see the one by one. First one is flame hardening. So here in flame hardening you can take the steel and by using some oxyacetylene gas flame you can do the heating the steel up to some temperature around some 850 degrees centigrade. Then immediately after heating you can do the cooling by using the water quenching. So you can spray the water. So because of this heating and cooling, so the structure it will change the entire surface, it will change this microstructure from austenites to martensite. So this is called flame hardening. So here example gear they are taking. So by using this gear you can take the oxyacetylene gas flame, we are doing the heating. So then immediately by using water pipe they are doing the cooling. So we are doing like this. So the properties of this gear it will increase. So it will have high wear resistant surface and then it will withstand some impact loads. This is about flame hardening. It will be suitable for carbon components around 0.4 to 0.9% carbon. Next one is induction hardening. For this induction hardening, we are in place of flame hardening, we are using this induction. We can use the current, electric current. So here we can fix the specimen. So we are passing this electric current through this specimen. So because of this magnetic field, so it will resist the current flow in this steel. So because of this is resistance, so it will generate this surrounding magnetic field and then it will heat up to some high temperature. So then automatically after heating by using the water we can do the quenching. So that is the only difference here. So we are passing the high frequency current, so the specimen it will resist this current flow and then it will heat within a fraction of seconds to the high temperature. So this is called induction hardening. So where we can use this one means for crankshafts, camshafts, connecting rods, cylinders, all these components they will do this induction hardening. So next coming to surface hardening, carburizing process or case hardening process, like gears, some small nuts, bolts, all these machine parts. After manufacturing, they will do this carburizing process. So by using this carburizing process, you can take the steel, heat up to some temperature. So then immediately we can do the cooling. Because of this heating, we are adding some carburizing medium along with this heating. So what will happen means that carbon or nitrogen atoms, it will dissolve into the top surface of the steel. So it will form as a one layer. So because of this, the top surface, it is having highly tough core. So it will give the more strength and hardness. So the properties will increase. So this will be used for gears, cams, bearings and clutch plates. So for normal carbon content 0.7 to 0.2%, we can increase the carbon content. So here what we have to do means we can take the gear along with this carburizing medium. Here we have to keep, we can do the heating. So this then reaction will occur at this temperature. So it will release the carbon atoms. So that particular carbon atom, it will dissolve into the top surface of the gear. So then it will have high tough core. So here three types of carburizing processes are there: solid carburizing, liquid, gas. So solid carburizing means, so this is the steel parts, we have to be packed and keep it here. Surrounding we are having the carburizing medium, that is called charcoal plus barium carbonate, and here we do the heating up to some 200 or 300 degrees centigrade. So then the reaction will occur. So it will release the carbon atom outside. This particular carbon atom, it will dissolve into the steel surface. So this is called pack carburizing. So coming to liquid carburizing, so same process in place of solid. So here it is in the steel parts, we will keep it here. Surrounding we are having the this gas. By using this medium, we can do the heating, and then the reactions will occur. So it will also release the carbon atom. So same like gas carburizing. So here also it will be used for mass production. So here we can use the some different gases like ammonia, that gas we can use. So after heating, it will release the carbon and nitrogen atoms. So it will go and insert into the top surface of the components. So next one is nitriding. So it is very useful for this nitriding process. It will take more time. So we'll keep the steel components here, and then we can send the ammonia gas. So this fan will circulate this gas around this, and then the reactions will occur. This ammonia, it will release the nitrogen atom plus hydrogen. So that nitrogen atoms, it will observe the top surface of the steel. So this is called nitriding process. So here the depth of nitriding is around 0.2 to 0.4 mm. It will increase the wear and corrosion resistance, high fatigue strength. So compared to carburizing, nitriding is having more advantages. So this is about nitriding. So like cyaniding process also, both carburizing and cyaniding, that medium only it will be having different. So process is same. So this is about various surface and case hardening process. Thank you.